Okay guys, here we go. Section 2.6, linear equations in two variables. Or sorry, linear inequalities. Linear inequalities in two variables. So, an inequality means not necessarily equal to. Okay, so inequalities, when we talk about inequalities, we are talking about greater than, less than, greater than or equal to, less than or equal to. Okay, so that's what we're talking about with these. Okay, and if we're talking about a linear inequality in two variables, then the linear inequality might look like this. 2x plus 3y is greater than or equal to some number, I'm going to say 6. So this is a linear inequality. Now the reason it's linear is because if I graphed this, it would make a line. Okay, so that's what makes it a linear equation. We could rewrite that so it looks like y equals mx plus b. Okay, so that's another reason it's a linear inequality. And we start off by being given some ordered pairs and asking if it's a solution. Okay? Is this point a solution? So it's easy. This is one of the easier things that we've done so far. All we do is we plug it in. If it makes a true statement, then it's, if it's true, then we say yes, it is a solution. If we plug it in and it's incorrect, then it's not a solution. So let's try it. Plug a 0 in for x and a 5 for y. 2 times 0 plus 3 times 5, is that greater than or equal to 6? 2 times 0 is 0, 3 times 5 is 15. Is that greater than or equal to 6? Yes, it is. So 0, 5 is a solution. Okay? Let's say they gave us another one. Negative 6, 2. Is that a solution? Well, like I said, the way that we do that is we plug it in. We plug it in. So I'm going to have 2 times negative 6 plus 3 times 2, and I want to know if that's greater than or equal to 6. 2 times negative 6 is negative 12. 3 times 2 is 6. Is that greater than or equal to 6? Negative 12 plus 6 is negative 6. Is negative 6 greater than or equal to 6? No, it's not. So is that a solution? No. So the first types of problems that you'll see in this section look like that. Okay? They will give you an ordered pair, they will give you a linear inequality, and you tell whether it's a solution. And the way that you tell whether it's a solution or not is by plugging it in. Okay? So then we progress to linear inequalities that they want us to graph. And they want us to graph and shade. Okay? So the directions might say something like graph x is greater than 2. Okay? So I'll do this up on the board there. So x is greater than 2. What kind of a line is x equals? Well, x equals represents a vertical line. So I need to go to 2, okay? And I need to make a vertical line through 2. Now, there is something that we have to look at and notice. This says x is greater than 2. So if it says x is greater than 2, it means that 2 isn't a solution to that. If I said, okay, x is greater than 2, what happens when x is 2? Not a solution. Why? 2 is not greater than 2. So when I go to make my line, I can't make a solid line through 2 because 2 is not a solution. So what I have to do is make a dotted line through x equals 2. Okay? Again, if I have x equals a number, we talked about this in the previous section. If you have x equals a number, Okay, x equals 2. We know that's a vertical line. We know it's a vertical line through 2. But, being that it's greater than, we need to make that dot. So, now, I look at this, and I need to figure out where I'm going to shade. Well, I want the solutions to be greater than 2. So where are the solutions greater than 2? Okay, the solutions are greater than 2 are to the right of this line. This is greater than 2. 5, 6, 7, 12, 15, those are all greater than 2. -1, -2, -6, -12 are not greater than 2. We want to shade where the solutions are. So I'm going to end up with a marker that doesn't work. Shading over here, okay? So this is where I shade, okay? It doesn't have to be as extensive as the shading that I'm doing. This marker does a pretty good job, so that's why I went a little extreme with that, okay? And I'm gonna expect you guys to be spending 5 minutes coloring. It's not coloring class, okay? That is, x is greater than 2. Okay, so let's look at another one. Okay, let me clear that out. 1, 2, how many times do you take it? 3, 4 times. Excellent. All right, so let's say I had this. Y is less than or equal to a -1. Well, I have to first think, what kind of a line is y equals 1, or y equals -1? And that would be a horizontal line. So I go to -1 on my y-axis, okay? I go to -1 on my y-axis, and I want to make a horizontal line. Now, this one is less than or equal to, so if it's less than or equal to, it's going to be a solid line. So I'm here at -1, I make a smooth. I guess I never switched that. My mistake. So I make a line through, a solid line through -1. And now I want to be less than -1. Where are the values for y less than -1? Well, in this case, the values for y are less than -1 below it, at -2, -3, -4. So that is where I shade, okay? And that is my graph. All right? Makes sense? Let me give you guys one to try. Try that one there. X is less than 4. X is less than 4. Okay, so what kind of a line is x is equal to 4? Well, x is equal to 4 is a vertical line through 4. 1, 2, 3, 4. I make a vertical line through 4. I'm just going to leave it like that for now. Okay, vertical line through 4. Now, the only mistake is I made it solid. And we know this has to be dotted. Okay, because it says x is less than 4, not less than or equal to 4. Okay, so I make a dotted line. Now, where are the values smaller than 4? If I'm standing here at 4, where are the values smaller than 4? That would be to the left. So I need to shade over here. Okay? One more of those I'd like you guys to try. Let's do y is greater than or equal to 2. Okay? Y is greater than or equal to 2. Okay, so what kind of a line is y equals 2? Y equals 2. Y equals 2 is a horizontal line through 2. 1, 2. Horizontal line through 2. Now, I want it to be greater than or equal to 2. So where is it greater than or equal to 2? Above the line. Okay, and notice it's greater than or equal to, so a solid line is okay. If you happen to do that on a homework and you use the pen and you're like, oh man, it's a solid line, and I wanted it to be dotted, just make a note there and say, this should be a dotted line. I'll give it to you. All right, I'll give it to you. All right, y is greater than or equal to 2. So, we have one last thing to look at in this section. One last thing to look at. And that is when we have a oblique line or a diagonal line. Let's say I have y is greater than 4x minus 1. So my suggestion to you would be to plot points as if it were y equals 4x minus 1. So to do that, we've got to go to -1 and put a dot. So I go over here to -1, right? And I put a dot. And then I've got to go up 4 and over 1. 1, 2, 3, 4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Now, if it's greater than, I need to make it a dotted line. Okay, so I'm going to make a dotted line. And there's two ways to shade. Okay? I'm going to show you both ways. And you do whatever way that you is easier for you. You have to pick a point that's on one side of your line or the other side of my line. So I'm going to pick over here. I'm going to pick 1, 2, 3, 4, 5, 0. I'm going to pick this point right here. Okay? And if this point, when I plug it in, is a solution, if it makes a true inequality, then I'm going to shade this side of my line. Okay? If I plug in this point and it doesn't make a true inequality, then I have to shade the opposite side of my line. Okay? So let's see. That point is what, 5, 0? So that marker's not going to work over there. Is 0 greater than 4 times 5 minus 1? Again, I'm plugging in 5, 0. Is 0 greater than 20 minus 1? Is 0 greater than 19? No, it's not. So I can't shade this side of my line. I have to shade the opposite side of my line. Okay, so I go over here and I shade the opposite side of my line. Okay, so let me go through those steps with you again. Okay, let me go through those steps with you again. So you graph the line y equals 4x minus 1 in terms of the points. You plot those points. Once you plot the points, you look at your inequality and decide if it's going to be solid or dotted. We did that. Then to shade, you pick a point that's clearly on one side of your line or the other. And if it makes the inequality true, then you shade that side of your line. If it makes the inequality false, you shade the opposite side of your line. The other thing that you can do, is if you've written it in slope-intercept form, like we did, you can stand on your line. I'm standing at this point, and I'm going to say to myself, where is it greater? Where is it greater? Is it greater above that point, or is it greater below that point? And I think you would agree that it's greater above the point. So that's why I would shade that part of my line. Okay? I'll talk more about that in class when we do these. Okay? But that's the other way that you can do the shading. Okay? So I want you guys to try this one. Go. I'll be interrupted in a second. I've got a student making up a test this morning. This is early January. So I may stop it. Have to get them in here. Good morning, Alize. I'm going to get that ready for you right now. Just set up your camera, please.
All right.
Now you said it was the chapter test for chapter 6, right?
Yeah.
Okay. Take a look, it should be open.
All right, I've got it.
Okay. If you have any questions, please speak up. Okay guys, hopefully that gave you enough time to get that straightened out. I'm ready to rock here. Sorry for the delay. Go to 4. 1, 2, 3, 4. Put a dot. Down 2 and over 3. Down 2, 1, 2, over 3, 1, 2, 3. Down 2, 1, 2, over 3, 1, 2, 3. Okay, now I look and I see, do I want to make it dotted? Do I want to make it solid? It's less than or equal to. I need to make that a solid line. And now, for this one, I think the easiest point to pick is 0, 0, because it makes your math the easiest. So let's plug 0, 0 in and see. If I plug in 0, 0, and it is a solution, then I shade this side of my line. If I plug in 0, 0, and it's not a solution, I have to shade the opposite side of my line. Let's look. Is 0 less than or equal to -2/3 times 0 plus 4?